Good afternoon, everybody. Nobody. Already late, so maybe we quite tired, but please don't be tired because I will bring you a quite heavy discussion today. I am accompanied by my assistant, human AI. His real name is Irene, so AI. Okay, so I introduce her because she may be learning something. Yeah. Okay. Maybe first of all, we should pay tribute, respect to Mr. Simon Rick. He was a big contributor of PostgreSQL. Maybe we should take what is it time? 5 seconds, okay. He is the major contributor, and he is the one behind the PG audit, replications, point of recovery, and so many things. Thank you. And also I want to say Selamat Hari Raya for any one of you who maybe celebrate for tomorrow. Selamat Hari Raya Lebaran. Anyone from Indonesia? Oh, my brother. Okay, next. So it is me. Maybe for the one who didn't know yet, I'm running IT solution in Indonesia and Southeast Asian. We also are having some event in Bali and also in Singapore and in the past, PG Day, PG conference, etc. So I think enough from me. Okay, this is a memory from 2019 and when we are in the Bali PG conference. Yeah, some of them is here right now. Raise your hand. Okay. Okay, so PostgreSQL is derived into 11DB Postgres, and this is our product. So basically, this is a proprietary, but we also are following the the versioning of the Postgres. If you want to test the 11DB Postgres with the encryption, you can go to 11db/.asia/register. So 11DB Postgres already implemented in so many clients in Indonesia. So you can see the logo here. It mostly is corporations. So this is something like we take a part of is we are avoiding this corporation not to use Oracle and instead use Postgres. So this is our milestone. Maybe I will skip. So maybe the question is why we need encryption in RDBMS? Because I saw from the beginning since last day, so many students, so I have to start from the beginning. Why we need encryption in RDBMS? So first, it is business need secure transaction. Transaction should be secure by RDBMS, not NoSQL or any kind of things, because business need to be secure by atomicity, consistency, isolation, and durability. So the transaction also need to be by something like encryption or anything else, and then multiple party involved in data management, since the data is designed, and then there is a business development, solution architect, data analyst, administrator, and etc. There are so many parties involved. So if we don't create privilege escalation, right privilege escalation, maybe we have facing some problem because maybe there is some data breach. Yeah. So also we need to comply with GDPR, PCI DSS, and ISO 27001. It is for data management. So because there are so many compliant regulations nowadays, I think we need to move forward into something better. It is, in this case, is encryption. and also minimize the potential fraud, since usually internal fraud is caused by internal. Yeah. If you had any question, feel free to ask. So maybe we can elaborate more information. Okay. Based on the analysis that we conduct to the regulations for this GDPR, we saw some articles which is indeed require first unauthorized. So we have to create something like authorizations method, a better authorization method, and then we can see encryption, and and then only personal data which is necessary, blah blah blah. So based on these articles from GDPR, it is concluding that encryption is required for creating a better security in data management. And also, we try to check also in ISO 27001. There is some articles also regarding encryptions, cryptography, access control, and prevention. And we in Indonesia we have a law derived from GDPR. We call it UU PDB, Undang-Undang Perlindungan Data Pribadi. It is also mentioning something like before, then about access and security level. Okay, so this is enough to us to go forward. Why we should have something like a better encryption, better security in data management. So what is the challenge? The challenge, first, I think when we talk about encryption, we should understand that in this recent world, there is already a quantum computer can do their work. Even though maybe only a very simple one to calculate, but it's possible. Some encryption that we use right now, we call it not quantum safe. So we have to use the encryption which is quantum safe. There is issue from NEST, I think, about information which encryption that should be used in business. So it is comply with the quantum safe. And then also quantum safe, that's the first challenge that we should comply. And then the compliance to end-to-end security. To comply the end-to-end security, I think we should implement something like SSM, hardware security modules. And then, but it should also be easy to use. It's we call it a transparent or seamless. So we should have an encryption method which is quite transparent or quite easy to use. And then support multi-factor for authentication and authorization. Of course, backup and restore should be there. And then, it should not be it should not be performance degradation. Yeah. So these points that we try to analyze before we create this method, and then we try to create column-based encryption in the RDB in the Postgres. Actually, it uses data type, and then because it is column-based, so it has to have index, so it is able to search fast enough. Because if we encrypt the column and then we want to search inside the encrypted column, so we have to scan and to decrypt. So it is not flexible, it's not efficient. So maybe it is maybe for the student who maybe didn't really understand about data state. Yeah. So there is three state of data. First is data address, which is the data it is on the storage. And then the data in transit, it is when data transmitted in the network, and data in use, it is when the data in the memory. So if we talk about encryption, which state we should encrypt? Usually we prefer to use at least the data at rest, and then data in transit, maybe in use, maybe not, maybe yes, maybe not. So data in transit is very easy because we already have TLS, SSL, and VPN, something like that. But data at rest may be another challenge. But some technology can be used, like storage-based encryption. So I can go next. So if you use like something like this, storage-based encryption, it is very easy because the database didn't know it is encrypted or not. This is in the file system or in the operating system. And we can also create encryption in the application level. So the application itself encrypt the data before put on the database. So the problem is in the applications. This also can be done, but this is also another problem raised because how we manage the key. And then the third is the encryption and decryption is done by the database. So we can say it is transparently from the applications because application didn't know whether it is encrypted or not. Also, encryption didn't know where is the key to encrypt and decrypt because it is done by database. So we choose this approach. Yeah, the encryption is done by database, and yeah, it is. So based on the picture, you can see this is the Postgres, and this is the agent. We create an agent for Postgres. So this agent function for facilitate the database. For example, like DBA access to the agent, and agent will modify something setting in the database. And the agent itself communicate with SSM. Okay, maybe anyone understand about or maybe see about SSM? Raise your hand. SSM. Okay, thank you. And we also create a mobile application. We call it Charaka. Charaka is Sanskrit, means messenger. Is that correct? Yeah. So we use mobile help for authentications because in the encryption we can encrypt the data inside using data type, but how we can ensure the user can access? So we create another type of authentications, and by using Charaka as the mobile apps, we can create something like offline OTP. Yeah. So applications in the protection level, it should connect first to the Equnix out service to get a token. Session. Yeah. To get session, this session would be used to connect to the database. So when application with their connection string breached by some attacker, the string, yeah, which is usually put on the code, cannot be used for attacker to connect to database, since it should require to use communication to the Equnix out service. That's another kind of protection that we develop for SA. SA means Equnix Seamless Encryption. So, yeah, this is for applications connect to the Equnix out service. We will show you the demo later. And after they get the content string, they can access to the database. And when database is restart, this database cannot be restarted by itself without any consent from the owner. So the database owner used Charaka Mobile to give consent whether the database able to be restarted or not. Because trying to restart the database is another security concern. We can trying to take a key or maybe something else from the database. So this picture is a complete explanation about the needed of implementation of encryption in 11DB. I will tell you more a bit about index and anything else later, but at least you can see the topology first. So what we call it end-to-end encryption, it is the key for encrypt and decrypt. It is on the SSM, and database will inquiry to the 11DB Postgres before they can get the key from SSM. Yeah. So nobody, whether the database or the agent, has access persistently to the key. Okay. Maybe up to this step, any questions? Or I just move first, yeah? Okay. So this is the demo explaining about how we implement the encryption in the database. I will start and stop while I'm explaining the steps. Start. Okay. Okay. So this first time, one should register to the system. You can use 11db.asia register, and this registration we collect to create the profile of user, and then when user register and download the package, inside the package there is what is it? We call it random seed to create the synchronous OTP. Okay, maybe it's just I will need to faster a bit. So at the first time, we only support online SSM, but later you can use SSM. Or you can use TBM. TBM is Trusted Platform Module, which is lie on the board usually. TBM can act as a SSM, but very less functions. So this already done. And then we will and linking the applications. So yeah, we download from QR code, and then because we are not registered yet into Google Apps, so sorry, we have to download it manually, and we have to install manually. Okay. And then registration, it is from email. We put on the Charaka to link the mobile phone into the system to to link us to the mobile phone. Okay. Okay. So we create a package, Debian and RPM. So you can try to use Deb or RPM. Yeah. This is installing. After installing, so the database already there. the agent also there, and also we install lib pum. If you wish to try to install, you have to be careful, because this installation put lib pum on your OS, and then your OS becoming more secure because there is another kind of authentications. Like you can see sudo ls-l. So before we don't ask challenge, right now they ask for challenge. This challenge should be used this mobile applications. We have to put this number to the mobile apps. And then we get the response from the mobile apps and put on the host. Okay, so that stage is we enabling the sudo into 2FA using offline OTP. We call it offline because the host and the mobile is not connected, and I mean the host didn't connect to the mobile, of course, connect to the internet, but between host and internet, any connection. Okay, so this is why we call it 2FA, offline OTP. Sorry, yeah. Okay, and then this is also the main reason of having 2FA is to preventing the Postgres starting up without any consent. So we also already start the Postgres, but it didn't finish the starting up, waiting for OTP, and we should open the website localhost locally, and we use the same mechanism to FA. Okay, then the database starts. So that's the reason why we enabling 2FA. So this demo for showing the encryption. Yeah. First thing first, we using user. Yeah, you're creating user, database user. Okay. Okay. So, and grant SL1, SL2, SL3, the role we use for level of access privilege. Okay. Okay. So we connecting to the system using trial one. It means the owner, and the owner create another user called Ananta, and Ananta has SL4, and Budi has SL2. It means Ananta has higher privilege than Budi. And then, yeah, this normal, grant all privilege to schema public, on schema public to Ananta and Budi. Okay. Then we will login as Ananta, and then we will create table and is okay. Begin, there's a first column, and the second column username is varchar, and the third column is mother. This name is ASEC. ASEC is our data type. This is encrypted data type. And then we insert the data. Okay, we have 3 row, insert, okay, then we create index. This index is special index created for this kind of data type, exact. So therefore, by using this index, so we can search, unless we cannot search. We want to name like, we can use like. Okay, can search. And then we log in as Budi. Remember that Budi only level 2. So Budi cannot see. But this in this type, wait a minute. Budi is not granted permission to table. It is Postgres, not us. Yeah, we have to grant permission to table. Grant all on users to Budi. So Budi can access the table. But still, Budi can access, but Budi cannot see because Budi doesn't have SL4. Because when Ananta create the when Ananta creates, Ananta is level 4. So, yeah. So Budi will try to select, can see, but cannot see the plain text because it doesn't have the same rights with Ananta. So we have to grant SL4 to Budi, so Budi can see the plain text. This is a real case demo. Okay, Budi can see the result. Any question perhaps?
Okay. Any questions?